Can you hear me?
천재적인 이론 물리학자 스티븐 호킹. 젊었을 때부터 그는 세상을 관찰하는 방법이 남달랐다.
You better hurry up because they're getting further away. Closer one's at about 6 million miles an hour and the distant one's at about 200 million miles an hour.
그렇게 행복한 시간을 보내고 있던 호킹과 제인. 둘은 행복한 결혼 생활을 꿈꾸고 있었다. 그런데 호킹에게 충격적인 일이 벌어지고 만다. 갑자기 온몸이 마비된 것. 건강하던 그에게 갑작스럽게 찾아온 것은 루게릭병. 호킹의 병은 21살부터 시작되어 점점 몸을 마비시켜갔다.
This is a yes or no. It would be the greatest achievement of science since Einstein's theory of relativity.
Yes.
호킹의 근육은 점점 마비되어 갔고 더 이상 손으로 펜을 쓰기 어려운 상황까지 이르렀다. 하지만 호킹은 연구를 멈추지 않았다. 평범한 삶을 살 수 없다는 것이 오히려 더 큰 원동력이 된 것일까? 호킹은 물리학자들을 깜짝 놀라게 한 엄청난 증명들을 해낸다. 우주 시작에 대한 실마리, 일반 상대론적 특이점, 블랙홀의 열복사. 그렇게 호킹은 천재적인 이론 물리학자로 인정받게 되었다. 폐렴으로 인해 호킹은 목소리를 잃어버렸지만 육체의 문제는 호킹을 좌절시킬 수 없었다. 스티븐 호킹은 강연을 시작할 때 항상 Can you hear me? 제 말이 들리나요? 라고 말했다.
Can you hear me? Can you hear me? Can you hear me? Can you hear me?
자신의 목소리가 아닌 기계음으로 대화를 하는 다소 낯설게 느껴질 수 있는 상황을 그만의 방법으로 재치 있게 표현한 것이었다.
What worries you the most about the future of the universe?
I am not worried about the future of the universe. The universe will continue whatever happens. But the future of the human race and of life on Earth is much less certain. Can you hear me? While there's life, there is hope. And there was also a young woman called Jane, whom I had met at a party. Getting engaged lifted my spirits, and I realized if we were going to be married, I had to get a job and finish my PhD. I began to work hard, and I enjoyed it. The big question in cosmology in the early 60s was, did the universe have a beginning? Many scientists were instinctively opposed to the idea because they felt that a point of creation would be a place where science broke down. One would have to appeal to religion and the hand of God to determine how the universe would start off. Two alternative scenarios were therefore put forward. One was a steady-state theory, in which as the universe always expanded, a new matter was continually created to keep the density constant on average. By the time I began my research, the steady-state theory was already in trouble with observations, but the final nail in the coffin came with the discovery of a faint background of microwave radiation in 1964. The only reasonable interpretation of the background is that it is radiation left over from an early very hot and dense state. As the universe expanded, the radiation would have cooled until it is just the faint remnant we observe today. But there was a second alternative to a beginning in time, which is a bouncing, or even cyclic, universe. Perhaps the universe had a previous contracting phase, and that it had bounced from contraction to expansion, at a high, but finite density. This was clearly a fundamental question, and it was just what I needed to complete my PhD thesis. General relativity predicted that the universe should have a beginning. Up to 1970, my main research interest was in the Big Bang singularity of cosmology, rather than the singularities or black holes that Penrose had shown would occur in collapsing stars. My work on black holes began with the Eureka moment. Shortly after the birth of my daughter, Lucy, while getting into bed, which my disability makes a slow process, I realized the area theorem. If general relativity is correct, and the energy density is positive, the surface area of the event horizon, the boundary of a black hole, has the property that it always increases when additional matter or radiation falls into the black hole. Moreover, if two black holes collide and merge to form a single black hole, the area of the event horizon around the resulting black hole is greater than the sum of the areas of the event horizons around the original black holes. The area theorem and no-hair theorems were tested experimentally by the LIGO Gravitational Wave Observatory. On the 14th of September, 2015, LIGO, for the first time, detected gravitational waves from the collision and merger of a black hole binary. Since then, LIGO has reported 4 more detections of black hole mergers. From the gravitational waves emitted as the final black hole settles down to equilibrium, it should be possible to test whether this black hole is described by the Kerr solution, as predicted by the no-hair theorem. From the early part of the waveform, one can estimate the masses and angular momenta of the initial black holes, and by the no-hair theorem, these determine the horizon areas. These can be compared to the area of the final black hole to test the area theorem. The data is not yet good enough to do this, but in the near future, it should be possible to test the area and no-hair theorems using gravitational wave observations. With many more gravitational wave detections expected, and the opening of a third laser interferometer, called Virgo, in Italy this year, I am excited by the possibilities this new era of gravitational wave astronomy will bring. But we must also continue to go into space for the future of humanity. I don't think we will survive another 1,000 years without escaping beyond our fragile planet. I therefore want to encourage public interest in space, and I've been getting my training in early. So let me finish by reflecting on the state of the universe. It has been a glorious time to be alive and doing research in theoretical physics. So remember to look up at the stars and not down at your feet. Try to make sense of what you see and wonder about what makes the universe exist. Be curious. And however difficult life may seem, there is always something you can do and succeed at. It matters that you don't just give up. Thank you for listening.